Alright, so in this video we're after the equation of the graph that we see. And I think it's going to be easiest to write this as a sine function. Because we know that our basic sine graph looks like this. And so we can see that it looks like the graph that we're given looks like a sine graph that's been flipped upside down. So once we find that amplitude, which is just this distance, we can make that number negative. So it looks like our amplitude should be -1, and again the midline of our graph is the x-axis, so it has not been shifted up or down. And so we can read the period. Looks like our graph goes through one full cycle in a distance of pi. So that means if I plug pi in for the period, that means that b has to be 2. b has to be 2, and if we just take this to be a sine graph, it's still starting its cycle at the origin, so it hasn't been shifted left or right. So to find c, just set bx minus c equal to 0. And since this graph hasn't been shifted, it's only been flipped upside down, then we can take b to be 2, x to be 0, and that means that c must be 0. So the final equation would be y equals negative sine of 2x. And we can check that again. Let's see, maybe if we take a value, say this one is 3 pi over 2, we should get a value of 0. So let's see if we plug 3 pi over 2 in for x, the 2's would cancel, and that gives us the opposite of the sine of 3 pi. And we know that our original sine function we sketched here should be 0 at all values of all multiples of pi, and so that seems to make sense. That would give us a value of 0. So that seems to check. So we can use that as an equation of the given graph.